All right, guys, so we're starting section 4.3. We've got section 4.4 review and a test, so we need to make sure and get this stuff down. If you're having questions, you do need to come talk to me. For 4.3, we're talking about something called direct variation. It's kind of a weird explanation, but I promise you we've been kind of doing this already. So when y varies directly as x, and guys, the order that that's set in is very important. When y varies directly as x, an equation can be written in the form y equals kx, which we've been sort of doing that, where k is the constant of variation and k cannot be 0. There are different ways to do direct variation and the ways it can be presented. So let's look at tabular form. Now we've already been kind of doing these guys in a different way. We've got two tables here, table A and table B. We're going to find the constant of variation, or the k, for both tables. So when you do this, guys, I'm going to scroll down a little bit here. When you do this, guys, we're basing this out of y equals kx. But since we're trying to find k and we're given x's and y's, I want to solve this equation for k. And the way to do that is I divide both sides by x. So what I end up with is k equals y over x. And we've seen this when we did slope before. We have our y's over our x's. So what we're going to do is put the y's over x's, simplify, and see if it's consistent. So let's take table 1 first. Let's look at the points. The first point is 5, 10. Well, the 10 is the y, the 5 is the x. So I'm going to go ahead and see what that is simplified. 10 divided by 5 is 2. We move to the next one, 6, 11. That's 11 over 6. Well, when I put that in my calculator, because that's kind of a tough one, I get 1.8333. Then I do the next one. I have 7, 12, so 12 over 7. I got that to be 1.714. And the last one's 8, 13, so I put 13 over 8, and I get 1.625. So let's hold that together for just a second, okay? Now let's look at our table 2. So we do, again, the y's over the x's. My first point's 1, 3, so I have 3 over 1, which we know is 3. I then have the point 2, 6, so 6 over 2 is also 3. I have the point 3, 9, so 9 over 3 is 3. Then I have the point 4, 12, which is 12 over 4, which is also 3. Now, if you're going to have direct variation, the k has to be constant. If I look at table 1, each one of these numbers was completely different. So there is no constant variation here. But if I look at table 2, all of them ended up being the same thing, kind of like what we did the other day. So that means we do have a constant of variation. So I'm going to erase this. You should have it. Right below this, it says table blank has direct variation since k is constant. Well, since k was constant in table 2 has a direct variation. So keep that in mind when you're doing these, guys. It's sort of like what we were doing with the in 4.1, I'm sorry, where we took the change in y over the change in x. If all of those were the same, then we had a equation. If it didn't, then we didn't. So keep that in mind when you're doing these. Sorry, I got a little tongue-tied there. Now, number 2, we can look at it graphically. For direct variation, that means y equals kx. What that essentially means is that the y-intercept is 0. And what we're going to put down here in a little star is there is not anything after the x. So, for example, if I had y equals 2x, that's good. Y equals 1/2 x is also good. But if I said y equals 2x minus 1, I do not have direct variation anymore, okay? So when you're doing these, you want to look for first that it has 0 for the y-intercept, second, that it has nothing after the x value. So let's look at a few graphs. It says, which of these graphs shows a direct variation? Well, guys, it said the y-intercept. Sorry about that. It says that the y-intercept is 0. Well, guys, this is your x-axis, this is your y-axis. So if we're looking for something that has a y-intercept of 0, it needs to be a straight line that goes through the origin. And these are really easy to pick out. Remember, the origin is 0.00. So if we look at the first one, it's a straight line. It goes through the origin, so that one is direct variation. If we look at the next one, it is a straight line, but it doesn't go through the origin. That one doesn't work. If we look at the bottom left one, it doesn't go through the origin again, so it doesn't work. But the last one does go through the origin, is a straight line, so it does have direct variation. Guys, that's a really easy type of question. Be careful and remember what it's supposed to be. Let's go down to the bottom. Now, this is the fun stuff. This is equation form. It says, which of the following equations has direct variation? Well, if you notice, when it gives us the equation form, it's solved for y, which means when we solve for y, it needs to equal a number times x, okay? So let's look at this first one. Y equals 6 over x. It's already solved for y, but it's not a number, then x. That one's not going to work. Number 2, y equals x plus 6. Well, that's x plus a number. That's not going to work. Then we have y equals x to the 6th. That's still not x and just a number, so that's not going to work. But if we look at y equals 6x, now we have the form y equals kx. Now the bottom ones are not solved for us. We have to solve them for y, okay? So I have 6y equals x. To get y by itself, I need to divide both sides by 6. And I get y equals 6, or x over 6. Again, that is not direct variation. Oh, I'm sorry. Oh, man, what am I doing? This is different than the one above it. I almost messed up there. This one's kind of weird because this is really 1/6 x, and 1/6 is a number times x. This one is direct variation. Sorry about that, guys. Be very, very careful. I have y over x equals 6. Well, to get that x out of the y, I have to multiply both sides by x, and I get y equals 6x, which is also direct variation. Now the next one, y times x equals 6. I have to divide both sides by x. Oops. And when I do that, I get y equals 6 over x. Now that's different than x over 6. This one's not going to work. Okay, so be careful. Those are two good examples. Then the last one, to solve for y, I have to subtract 6, and I got y equals x minus 6, which is not by itself. So be careful on those, guys. Watch out for this one right here. That's the tricky one, okay? Let's go to the next page. We can also solve word problems, so I know you're excited about that have a direct variation relationship. It says if y varies directly as x, that's that phrase that we saw in the first one, and y equals 6 when x equals 8, we need to find y when x equals 12. So we're going to start off with our base equation, y equals kx. We need to find k, but luckily they gave us a pair. We know that when y equals 6, x equals 8. So I'm going to plug those in. When y equals 6, x equals 8. Now we just need to solve for k. So I'm going to divide both sides by 8, and I get k equals 6/8. But we can do better than that. If I simplify, I get 3/4. So what that means is, when I plug that in for k, is I have my equation, y equals 3/4 x. Now it says what's y when x equals 12? Well, that's y equals 3/4 times 12. And if you're going to put it in your calculator, be careful, which gives me y equals 9. So it's kind of tricky, so be careful. So let's do number 2. Now this one is where you really need to understand the phrase that it was using. It says the force required to stretch a spring F varies directly with the amount the spring is stretched. I'll reread that. It says F varies directly with S. So that means F is like my y, and that S is like my x. So I have F equals K times S. It says 10 pounds is needed to stretch the spring 8 inches. How many pounds be needed to stretch the spring 32 inches? So we just need to plug in our point. It says 10 pounds and 8 inches, so we need to plug those in. So the force is 10 pounds. That equals K times the stretch, which was 8. I need to divide both sides by 8 to solve for K, and end up with K equals 10 over 8. But we can simplify that to 5 over 4. I do not want decimals, so I'm going to plug that in for my K. F equals 5 over 4 S. Now it says I need to stretch the spring 32 inches. So that's a stretch, so I'm going to plug it in for S. So the force is 5 over 4 times the S value of 32. Now be really careful if you put this into your calculator. It'll be 5 over 4 times 32. You need to put the 32 in parentheses. If you do it right, you should get 40, and I believe that is pounds. So it seemed a little different because of the wording, but it was the same work that we had to do. Let's look at the last one. The distance d varies directly with time t, so it's like d is our y value. So d equals kt. Says if you have driven 175 miles for 5 hours, how long would you drive for 210 miles? So we have our distance d is 175 equals k times our time, which was 5 hours. So again, we just solve for k. 175 divided by 5 is 35, so that's what our k is. Now we plug it back into here. So I have d equals 35t. Then it says how long would you have to drive for 210 miles? So this time, guys, it's giving us the distance equals 35t. We do a little bit of division to solve for t, and you should get 6 hours. Now, guys, the only way to get good at this is to practice it, okay? I know that 2 and 3 can be confusing, but if it says y varies directly as x, you can use any two variables. The first one is like the y, the second one's like the x. Other than that, it's just solving equations that are a lot easier than what we've seen before. Guys, if it's giving you trouble, you got to come in here and get help. Good luck.